All right, today we're going to continue with long division. So we knew from long division we could take a polynomial and divide it by a binomial and do long division on it, and we also knew that we could use synthetic. So what we're going to do today is just go one step further and say if we do long division and we get a zero remainder, then we know that what we were dividing by had to be a factor. So the idea is to find a factor, we want to get a zero remainder. Okay, so that's basically our goal with the factor theorem. So the factor theorem says we need to get a remainder. So a zero of a polynomial must be a factor. So that means then if x plus 3 is a factor of this equation, then we must get zero remainder. So all we have to do basically is check that out. So if this is the case, let's do this one with synthetic. So if we put in -3, we're going to put that into 2, 1, minus 27, and minus 36. So if we do our synthetic, multiply, add, and multiply again, you can see we do get a zero remainder. So that means that x minus 3 is indeed a factor. So our whole point with doing this is to actually figure out those factors. So the factor theorem says that if it's a factor, then we have to figure out which are the possible factors. So if we look at this, we see our last term, our constant term is -6. So if it's a factor of the whole polynomial, that means our factor must be a factor of -6. Otherwise, it wouldn't work out. So that'll limit a lot of your choices. So we have 1, -1, 2, -2, 3, -3, or 6 or -6. So the best way to do it is just simply plug it in. So if we plug in a +1 into this case, we'd have 1 cubed, which is 1, 4 times 1 squared, which is 4, 1 again, minus 6. If we actually do that, we actually get 6 minus 6, which is 0. So that means x minus 1 had to be a factor. If +1 works, then -1 would be our factor. So if that's indeed the case, what we want to do now is do our long division to figure out the rest. So we know that x minus 1 was one of the factors. So let's do synthetic or long. Let's do synthetic. So we bring down the 1. 1 times 1 is 1. Add. 1 times 5. Add. Multiply again. We get a zero remainder again. So that means we know that our x minus 1 is a factor. So now, remember that our leftovers would be x squared plus 5x plus 6. So we could do long division again, but now that we got it down to a quadratic, it's probably faster if we just use our factoring like we did before. So what two numbers multiply to 6 and add up to 5? We'd have 3 and 2. So we'd have those two as our factors plus our x minus 1, and that would be our three factors for our original polynomial. And if we needed to figure out the zeros, then they would be the opposites, 1, -3, and -2. So the idea then is test first to figure out which is a possible factor, then do your long divisions and go on from there. So let's look at this one. So here's a quite complicated. We got x to the 4th, but we look at our last number of 12, so we know it's got to be a multiple of 12. So let's try 1. So if we plug a 1 into the equation, we'd have 1 plus 2 minus 7 minus 20 minus 12. So 1s are really easy because we just use the front numbers. So does that work? We get 3, -4, so we have -36. So that doesn't work. So 1 didn't work. So let's try -1. That's the next easiest one. If we put -1 in, that would be positive here, but then we get -2. Then we'd have positive 7. Oops, sorry, -1 squared would be still -7. So that one doesn't change. But then we'd have positive 20 and minus 12 again. So let's check that. So now we have 21 and 21. So this one is 0. So we know -1 worked. So that means we can do long division or synthetic division with -1. So if we put in -1, do our synthetic. So let's bring down the 1, multiply, add, multiply again, add, multiply again, add, and multiply again. We get 12 with remainder 0. So that works. So that means we know that x plus 1 is one of our factors. So let's just jot that down to the side. Now you can see our remainder. We still have a -12. It worked out that way. So we know that our zeros still have to be divisible by -12. We've already tried 1. It doesn't work. We tried -1. It did work. So we could try negative 1 again. So let's put that in. So if this was our equation, we'd have 1x cubed plus 1x squared minus 8x minus 12. So if we put in negative 1, we'd have negative 1 plus 1 plus 8 minus 12. That doesn't work. So negative 1 isn't going to work again. We only get the one of them. But let's keep going. Let's try 2. So if we put 2 into the equation, okay, so let's try 2. Oops. Okay, so if we try 2, that would be 2 cubed, which is 8, plus 2 squared, which is 4. 8 times 2 is 16, minus 12. So that doesn't work. So let's try negative 2. So negative 2 would be negative 8 plus 4 plus 16 minus 12. So that gives us 20 minus 20, which is 0. So that does work. So negative 2 was a valid one. So let's put that into our synthetic again. So we're going to go negative 2. We'll put that into 1, 1, minus 8, and minus 12. Remember, go from the previous answer, not the original. And let's do our synthetic. Bring down the 1, multiply, add, multiply, add, and multiply. It gives us a 0. So we know x plus 2 had to be a factor. And we're done. We got x squared minus x minus 6 is our final. So from there we can just do easy factoring. We'd have minus 3 and plus 2. So we'd have minus 3 and plus 2 again. So you can see we actually have 2 plus 2's. So we could even write this as x plus 1 times x minus 3 and x plus 2 squared. That would be another way of writing it. So either of those versions is fine. And that's it. So you can see with doing this kind of factoring, we just sometimes have to repeat it, test it a few times, but eventually we'll get all of the possible factors. And that's all.